entering a future where robots not only work in cages and assemble our cars. They may soon hand us tools, support our healthcare, or even assist us at home. For that to happen safely, the systems behind must be trustworthy from the ground up. Welcome to the SYSGO TechCast. I'm Ben from the Marketing and Communications team at SYSGO, and today I'm joined by Mario, our Director of Research and Technology. In today's episode, we'll explore how robots and cobots are transforming industry and how PikeOS plays a fundamental role in making them reliable in the real world. So, with that, welcome Mario.
Thank you, Ben, for inviting me today to this TechCast.
Can you please introduce your role as Director of Research and Technology and what you do at SYSGO?
So my primary role here as a research and technology director is really to scout for new directions, new ideas. The second part is really to bring those to life with funded projects. So we have actually an average 10 to 12 funded projects, which is quite remarkable given the size of SYSGO. And these are in different technology domains. So scouting, funded project acquisition, execution of such. These funded projects we usually do in the European level, so Horizon Europe. We have also European KDT projects, in addition also to some defense-related topics, and as well as national funded projects. So that's what my team and myself do at SYSGO.
Okay, wow, that is quite impressive.
Yeah, very interesting because I like different technologies thing, and I worked on so many different products from head-up displays to infotainment systems, TV, set-top boxes, routers, whatever, right? So that's where when you work at SYSGO, the nice thing is you get exposed to many different systems. We're in satellites, we're in planes, we're in trains, we're in cars, where everything where functional safety is used. And today the topic was industrial automation / robots, cobots, and I think that's also a field for us. I'll see us getting stronger in that domain as well.
And since we zoom into robotics today, how does SYSGO fit into the robotics and cobots ecosystem?
So our core product, PikeOS, is a safety certified operating system and hypervisor. And as such, we look at projects that require functional safety as the core element of the technology. And certainly robots and cobots, they are safety relevant. And as such, we support that particular industry. Of course, the primary focus is still on the OS and the hypervisor, not necessarily on system level, meaning when it comes to safety layers, system integrations, it's the job of the actual manufacturer or user of such robots that use then our operating system or hypervisor technology. And that's what we should mention in this context, that we're responsible for the lowest levels of a system, virtualizing such to accommodate multiple function. We call it a mixed critical function. So meaning safety and non-safety related topics in a robot space. It could, for example, be that we have a partition with like ROS2. At the same time, we have maybe some POSIX safety partition or a real-time OS that then isolates general functions from the safety functions. So that's where we come into play in this space.
That makes sense. PikeOS provides the safe and secure foundation for others to build robotic systems on top. You mentioned earlier that SYSGO has been active in industrial automation. Do you have examples for us and what you learned from these projects?
We had many different projects in the industrial automation space. So there was a while back this project FabOS. There was also a project Basis 4.0, 4.1, 4.2, which industrial automation was at the center of this. So was it primarily focused on robotics? Not only, because that's usually a secondary part. When you look at automation, there could be various different paths, but we had exposure to that. We also have partners that we often have in consortia that work in this field. But it is, when it comes to the traditional robotics, we are there, but the safety in those fields are often fairly simple, yeah, because they're caged environments, they're really sealed off environments. But nowadays the direction goes a little bit further. We have cobots, we have humanoids, yeah, and then what happens when humans come and intersect with that environment, right? That is, I think, our stronghold to say, hey, we have more and more interaction, and safety is about humans, and humans interact, and that means also here our core product has opportunities in this field. Yeah.
Right, once humans and robots share the same physical space, safety becomes a whole new challenge. From your perspective, what forces are really accelerating innovation in robotics and cobots today? Is it technology, society, economics?
We got to see clear directions, right? So when you look at society, let's start with that. Yeah, we're aging. Yeah, we're we need support. Yeah, and we're with an aging population. We need more and more support by machines. Yeah, so that's where I see really an advancement of these technologies moving forward, right? I think that is really a big driver. So on the contrary, right, we need to also see with such robotics and AI in conjunction with that, right? Because that usually goes very well together. We have generative AI and we train robots, cobots, or humanoids down the road, yeah, that do particular tasks, yeah. Now we say, okay, the aging population on one hand side, but now we also look at, the efficiency increase on the other side, right? So now we need to see, well, what will happen in a few years, right? So let's assume every industry would increase their efficiency by 30, 40, 50%. Yeah. And then people say, you have an aging population, but that still would not put a balance on such efficiency increases. That means we are not employing our people anymore, right? So we have other problems, society problems that are going to arise out of that. Some people say, it will still work out. I think this time it might not, yeah, because the efficiency increase is too much. And with Industry 4.0 and now Industry, let's call it, we can still call it 4.0 AI or 5.0, whatever we want to call it. I think the efficiency increase is just too much to really keep a traditional free market driven society, as at least when you look at the US, when you look at some European countries. I see issues, and I think many people also in Silicon Valley see issues with that, right? As they can foresee the efficiency increase being far beyond what society can absorb to still have good, full employment, or almost full employment. Yeah.
Traditional industrial robots were fenced off. Modern cobots are different. They are mobile, connected, and close to humans. So, how is safety evolving? And how does cybersecurity enter the picture?
Yeah, this is always a big topic when many people when you say, there's functional safety and there's cybersecurity, and there's like two completely different things. Yeah. However, they do intersect, and we always say, hey, there is no functionally safe system if you cannot secure it. Yeah, and I think that is at the root of the problem, is really you have a system that is somewhere and it's not secure, so people can infiltrate it in whatever way, and then disable the functional safety part, right? And that's where this interrelation really takes place. We need the systems to be secure in order to be safe. So this is one point, and then you say, yeah, why does that matter for us? Why is SYSGO interested in that? Well, we actually cover both. Yeah, so we have our core product is not only functional safety certified. That means we can cover the industrial automation standards, the IEC 61508 standard. We cover that up to SIL 3. That means if you create a partition in such a, let's say, system on chip that has safety functions, then we provide these core elements for you to later on get that such a certification. But at the same time, we also have a common criteria certification. That means we can basically categorize the security level of a partition, of an interpartition penetration. Yeah. So, and I mean, that is really the key. How can I get, if I have created such a partition and it is, let's say, in a robotic space and it does functional safety, how does it guard against the outside world, right? Because we could have some vulnerabilities there where people would like to attack that function, but when we can shield it, then we have achieved what we call it also a security separation. And for that, we have used the common criteria certification with BSI, and that's for our core product at EL5 Plus, which is quite remarkable to have that for the security certification and the safety certification for the same product, right? With not many companies have that actually. Now, robots and security is, of course, another topic. Yeah, so because the exposure, you always got to look at where you expose your systems. Yeah, and if I have a shop floor, yeah, it's usually an isolated environment. Yeah, so traditionally it would be an isolated environment. Yeah, and if you look at a traditional shop floor, it's all robots. Yeah, and they're usually caged. Yeah, because what matters is really the economics, and it needs to be as quick as possible. There's also a paradigm shift that it needs to be more flexible, that it needs to be more adaptable, that it needs to be, yeah, it needs to accommodate also people, yeah, sometimes, yeah, in some steps. And this is where now there's some technological advancements on robotics, yeah, with vision processing, with force feedback, etc., that enable us to make more sophisticated robots and more sophisticated steps in the manufacturing process. Yeah. But now we're going back to the security. Where do you need really the security? Because traditionally, if it's a wired device and you have that behind a firewall on your shop floor, well, your attack surface is pretty small. Yeah. Of course, when we then partition that further, the attack surface gets smaller and smaller as we're exposing less and less. Yeah. However, the advancement in the robotic space also have a lot of communication topics. Yeah, all of a sudden, these are completely flexibly floating around on the shop floor. You have 5G, low latency communication, maybe down the road 6G, deterministic communication, etc. All of a sudden, your attack surface for man in the middle and other attacks are becoming a lot more, becoming bigger. Yeah, so you could sit at the corner of a shop floor and sniff into the communication, so the attack surface becomes larger, and then we have to put other countermeasures on it, and that's where we really see down the road also with humanoids in your home space, or that here we have functional safety, but we also have a high security exposure because those robots are connected to Wi-Fi, to the home network. It's not such secure, but they can also be. Imagine what would happen if you can control a whole fleet of humanoids. Yeah, that's what people said also in automotive space, where you say, hey, you have a full fleet, and now imagine these are trucks and you can control all the trucks, yeah, because of a vulnerability. That would be like a big thing if you can all of a sudden control 1,000 trucks and let them run. Yeah, so that's why there are many aspects on that, and that's why with PikeOS we have at the foundation of such systems a good element to separate those and reduce attack surfaces in these robotic systems.
Yes, that dual certification, functional safety and cybersecurity, makes SYSGO's position super unique. Let's talk architecture. What role do things like partitioning, microkernels, or formal verification play in building trustworthy robots?
Let's start with the formal methods. Yeah. So when, a formal method is just a mathematical proof of something. Yeah. So now when we do safety certification, we are very process driven. Yeah. Why is that? Because there's in safety, one element of the functional safety is our systematic faults. And systematic faults, you must, as much as possible, eliminate. And how do you eliminate it is by having processes defined and following those. Yeah, so it's kind of a rule book that you need to follow. We have those in the different domains, like in automotive we have the ISO 26262, in industrial the 61508, and this is basically the rule book that we have to go by and do it. Yeah, so now one could argue, don't do the rule book, but we do it differently. We use formal verification. Yeah, so it is another approach to basically say on a particular system, I can test certain things and say, okay, it's not doing that, there's no bugs, that's it. Or I say, mathematically it cannot happen because I was proving it to you that this and this result can never be this and this. It's a mathematical proof. There's a big difference, yeah, on the method on how you go about certifying your system. Yeah? Now, I take a piece of code and just formally verify it. Then I would, one person would say, "Oh, yeah, of course you can." Yeah. Well, that's true, yeah, but it is not so trivial. Yeah, and the triviality is, for example, with very complex code functions, it's not so easy to test to a formal verification. That means formal verification by itself needs to flow into your design process. And you cannot say just retroactively, oh, let's do our PikeOS with formal verification, right? Or any other. That's usually not how it works. That means, we're looking at it in a different way and say some elements we design in such a way so that we later on can formally verify it and save vital test steps. And this is nothing more than an efficiency increase. It doesn't change the fact that it's better necessarily. Yeah, maybe it is. Yeah, but it is certainly this is more complex. That is the truth. Yeah, but it could also be more efficient, and that's a pure economic factor actually.
Interesting. So formal verification means careful system design from the start. In cobots, we expect robots to adapt to humans, but safety certifications require predictable behavior. How do developers reconcile those conflicting goals?
So when it comes to functional safety, we don't balance. The fundamental answer is at the priority is always the safety goal that you have defined in the context of what you're using the robot for. Okay. And to its capabilities too, right? So I mean, there's many different metrics of a robot system: the speed it moves, the sensors it has, or the whole, the reach, et cetera, right? So somebody needs to look at such a context and define what is safe and what is not safe. And then based on that, I define goals which clearly define requirements. And these requirements need to be met, and I cannot balance them. Of course, I could say, oh, I use a very slow robot that cannot, and then, well, that's fine. Yeah. But that means the safety goals are going to be lower and the metrics are going to be lower, but you're still going to meet them. So you have some design principles, yeah, and you're probably at the core, you always try to maximize your productivity. Yeah. But when you have an interaction with a human, there's no compromise. You have to meet those requirements. Now you can say, well, then eliminate those. I say, yes, that's your choice. Yeah. For example, one part of your factory, you say this is off humans because this needs to be 1,000 pieces. The takt time needs to be 1,000 pieces per minute, and there cannot be a human at all in any of the steps. Other areas are, oh, I need that complexity because there's a handover and this and that. I cannot, and then I need to balance that. And that's where the balance comes into play. Yeah? So I have the speed of the robot, I have force feedback sensors, I have maybe a strong communication, ultra low latency communication, the whole technology bricks that I need for those, I have those, and I can balance those. But at the priority is always the safety or even the security, right? Because we learned that without security, there's no safety. Meaning, I cannot expose certain, architecturally, sometimes it doesn't make sense to expose certain functions in a particular area because it wouldn't be shielded from both of that play into the design. This technology is at the root of manufacturers, right? I mean, they live off having high efficiency manufacturing because that makes up the price of the product. They want to have the lowest tech times and the highest productivity. Yeah, but safety cannot be compromised.
Okay, got it. Coming to the next topic. As we know, AI is changing everything: perception, autonomy, decision making. How do you see AI fitting into safety certified systems, especially for humanoids or smart cobots?
Well, it's very tricky. It's very tricky. Yeah, I mean, when we struggle, certainly, yeah, because we're a traditional OS hypervisor, and then you say, where do you use? Can we use AI in learning schedulings? Okay, yeah. So that's usually in deterministic systems. We is usually an input, yeah, and there's also quite some creativity, and you're saying AI, can it do it? So let's dissect it a little bit. Let's first look at where can I use AI in our development process. Yeah, where do I see advancements down the road, where do we see already advancements now, is certainly because we're process driven. Yeah. And I need to basically look at every little step in this process. It starts from the requirements gatherings, the testing, the design, all the V-cycle steps. Plus in safety, we do the V-cycle, and then we have additional testing environments to inject false, to do back-to-back testing, so more testing. And that's where I envision that we will increase incrementally our efficiency by supporting our development process on particular steps. Which those are and to what efficiency increase we can reach, I think time will tell in our experiments, but we're working on some parts in that area. The second part, we need to look at it in another perspective, and that's, we do functional safety, but also we have what we call the safety of the intended functionality. Yeah, that's a little bit different. So let me give you a difference, why that is different. So let's assume you have some kind of a sensor, yeah, and this sensor can fail, right? So it's a functional fault of that sensor. So, okay, then what I do is in a safety design, I say, okay, I need to surveil that sensor. So there's different methods. I can periodically check it. Is it still there? Or I compare this value with some other value. So many different ways of doing that. So this would be functional safety. Yeah. But now let's imagine this is a sensor that detects faces or humans or other objects. Yeah. That's then used in the intended functionality, right? And this is where the complexity comes when people talk, oh, a level 4 car, level 5 car. That's basically about the training models, yeah, what the training sets, and getting to acceptable safety levels. But what are those safety levels? Yeah, so is it safe to say, oh, my machine is operating safer than a human can do? Is that safe enough? Or what are the metrics, right? So, and this is where the SOTIF, or safety of the intended functionality, comes into play. But also our PikeOS can isolate those. And we have seen many designs where we have like LiDAR sensors, we have vision cameras, yeah, and then we do sensor fusion. Also in such designs, our PikeOS can really shine, as we can separate those functions from robotic functions or other non-safety critical functions. Yeah, so both apply, but the complexity level is completely different. Yeah.
If we look ahead, do you see robots and AI reshaping the world we live and work in over the next decade?
It will. I think it's a revolutionary, exciting time. Yeah, I was many years in Silicon Valley, and I remember my friend, he started working on neural networks and say AI, artificial intelligence. It was in the early stages. We followed it quite along, and then the processing power would increase, the models would improve. All of a sudden, you hear reports and say, "Oh, this AI backend all of a sudden can talk, it can understand context, et cetera, et cetera." So the evolution was there. We followed it, and now it won't go away. It will intensify. We have to learn to use it in an efficient way without breaking our complete society. Yeah, that's very important. So I don't think it could be a complete free ride. I think so. I think at some point in time we need to have some regulation in place. Yeah, otherwise we're going to fail as humans. No other chance.
What an exciting start to robotics, AI, secure embedded systems, but there's more to come. Follow us so you don't miss episode 2, where we'll explore how SYSGO is preparing for the next generation of autonomous systems. Thanks for listening, and see you again very soon.